Hello, my name is Nicholas Reed, and this is my lab 5. Choose your own adventure. The slinky drop is my topic, and this is for Physics 2211, Georgia Tech semester fall 2020. So, introductions. In order to conduct this experiment, we hold the slinky at arm's length, let it expand downward while holding the top, let it go, and observe what will happen first. Will the slinky fall overall, or will the slinky retract before it falls? Then we plan to analyze this using tracker and analyze the video and then try to recreate it in code. So this is the video I used for my analysis. I used the presenter's height, which I presumed to be the average human height. So it's 5'6", and I used that to determine the length of the slinky and how much it stretched, which was about a meter. So then I took this, and as you can see in the video, before the slinky drops, it contracts. And I believe this is due to the fact that the force produced by the spring of the slinky is strong enough to counteract the force of gravity until it can contract no further. So I graphed this in tracker using his height, and then I tracked it over here. You can see the graph that the tracker produced. It's a very quick clip, so there wasn't a lot of data points to control with, but these are the data points I had nonetheless. As you can see, that's how I tracked it downwards. So then I took this into code. So I had a few issues with the code here. I struggled a bit with this, and it doesn't work entirely, but it does work partially with what I wanted to do. So I tried to adjust one of the codes we had in the past. So I cut it down and I created sections. So I have visualization, which gives us our spring, the origin, and the ball. Which represents the end of the spring. We have the ball mass and the spring mass. Set up all the position vectors, counting, indexing, and then the delta and our time step. And then I also gave us our interaction constants and spring energies, which I looked up the spring energy for a slinky and I got 0.8. And then I have the contracted length, which is this is the rest length, so it's at 0.0254 meters, and then I set up my spring values. So then I made my calculation loop where I have F gravity and F the spring, and then I use the F net for the ball's position, and then I use F net S as a spring position and velocity. F net S designating the net force on the spring. And then I did an update on the spring values while continuing to increase my count and my indexing while giving it a time step, and then also including it all done once the calculation loop is complete. So this is the graphic created. It did not work exactly as I had intended, but it still did graph the spring moving downwards. I couldn't understand how to get the spring to actually contract and then move downward as a unit, but it still did move downward as I wanted it to. So I believe the program works successfully in some senses, but it definitely could be improved in later iterations. So the slinky didn't fall before the spring was fully compressed because the spring force was enough pulling upwards to keep the bottom of the slinky stable. This made the bottom of the slinky stay still until the slinky had compressed no more. This is really interesting since it was able to counteract the force of gravity until it had fully compressed, which almost gave it the appearance of levitation. And I thought that was one of the reasons I chose this project. I could definitely improve this by having more experience with Python, since this is my first class ever using it. And I would like to go back and make it so the program worked a little better as intended, and I wanted to create a better, more accurate model. I do understand the math behind this, and it's awesome since it was basically the mass due to gravity time, the force created by the mass times the acceleration due to gravity, counteracting by the force of the spring. As it's pulled closer and closer, the spring force decreases, which eventually it equals the mass of gravity, and then since the spring force no longer exists at one point, then it can no longer stay upwards, and then it will begin to fall as it would. Thank you for listening. This has been my lab on Lab 5, and have a great day.